Find the volume of the solid formed by rotating the region bounded by f of x is equal to square root of x is equal to 0, and x is equal to 4, 2 pi radians about the x-axis. Okay, if we draw a graph of the f of x is equal to square root of x, it looks like this, and we mark on the point 0 and 4. And what happens is we're going to take that region there that I've just shaded and rotate it round the x-axis, and as it rotates it will make a solid, as seen in this GeoGebra app here. So let's have a quick look at that. So the GeoGebra app I will put in the notes of this video. So we go to the GeoGebra app, and here we can see we have f of x is equal to the square root of x. If I start the animation, okay, what you can see is that it's actually now forming a solid, and what I mean, it's rotating 360 degrees, 2 pi radians around the x-axis. It actually forms a solid, and what we're going to do is use integration in order to find that the volume of that solid. One reason, what you've got to imagine is you've got lots of infinite amount of small circles, and we know that the area of the circle is pi y squared, but y is pi r squared, where r is the radius, but the r is the value of f of x at any point, so we get pi f of x squared, and to sum those we need to integrate. So we'll come back and look again at the applet at the end of the session. So the volume of revolution is pi between our two limits a and b. So our two limits are going to be between 0 and 4 of the radius, which is going to be f of x, so the value of f of x at any point squared dx. And if we integrate them, what we're doing is we're summing up all the little discs that make that volume. So applying that, we now get pi, the integral between 0 and 4 of f of x. So it's the square root of x, but we have to square it. The most common mistake is to forget to square it when you do this, dx. Obviously, if you square root and square something, you're just having to find the integral between 0 and 4 of x dx. Now, that gives me pi. Now, the integral of x to the n dx is x to the n plus 1 over n plus 1 plus c, provided n is not equal to minus 1. So this now becomes x squared divided by 2, and the limits are between 0 and 4. So we put the limits at the end. So leave the pi out until the very end. So we're going to get pi times 4 squared, substituting in the 4, divided by 2, minus 0 squared divided by 2. Don't always, in fact, assume that you're going to put 0 in here, that it will be 0. What would happen if this was cos x, for example? The cos of 0 is actually 1, so be careful. 4 squared is 16. 16 divided by 2 is 8, so we get 8 pi. Get nothing from here, so we get an answer of 8 pi cubic units. So if we go back to the animation, okay, and just reset, and then we'll start it again. What we can see is that this is being rotated around the x-axis, and you get this sort of solid being formed, and we found the volume of it. If I click here, I can get the integration that I've just done and get the answer of 8 pi. Okay, I'll put the GeoGebra applet in the notes of the video. I hope you understood, and I thank you very much for watching.